Alright, we're going to start the second half of 13.2 by learning the negative trig identities. Alright, so imagine a unit circle and pick any spot. So I'm going to choose this spot. We'll call that x degrees. And then picture negative x degrees. Okay, for those two spots, do those have the same x-coordinate or are the x-coordinates opposite of each other? Well, in quadrant 1 and in quadrant 4, your x-coordinate is positive for both. So because these two angles have the same x-coordinate, cosine of x is equal to cosine of negative x, because those two degree measures have the same x-coordinate. Okay, now let's compare their y-coordinates. Well, in quadrant 1, your y-coordinate is positive, but in quadrant 4, your y-coordinate is negative. So the y-coordinate of the negative angle does not equal the y-coordinate of this angle. It equals the opposite. Okay, and then the tangent will also be opposite. So if you imagine this having coordinates x comma y, and then the one down here having coordinates x comma negative y. So what would the tangent be? The tangent for this guy would be y over x, whereas the tangent for that one would be negative y over x. So the tangent of the negative angle equals the opposite of the tangent for the positive angle. Alright, let's move on to number 7. So on your paper, that should say sine theta, cosecant theta. So let's leave sine theta alone. And let's change cosecant of negative theta to 1 over sine of negative theta. Alright, we just learned that when you go from quadrant 1 to quadrant 4, or from quadrant 2 to quadrant 3, when you go to the bottom, does your y-coordinate change? Yes, it does. So this would become 1 over negative sine of theta. Alright, so the signs cancel. We still have a negative on the bottom, so 1 divided by negative 1 is negative 1. Okay, for number 8, let's change this to 1 over cosine of negative theta times cosine of negative theta. We could already tell from there that this is going to equal 1, but let's practice our negative trig identity. So the x-coordinate, when you go from quadrant 1 to quadrant 4, your x-coordinate stays the same. So cosine of negative theta equals cosine of positive theta. And these cancel out, and we get 1. So cosine, out of sine, cosine, and tangent, cosine's the only one that stays the same when you go from a positive angle to a negative angle. Alright, so I'm changing this to 1 over tangent of negative theta. Alright, we have not reviewed yet the cofunction identities, so let's take a break from number 9 and review these cofunction identities. Alright, so I'm going to draw a triangle. And the 90-degree angle, I'm going to call pi over 2, which is radians. So instead of 90 degrees, I'm writing pi over 2. Let's call this top angle x, which makes the last angle pi over 2 minus x. All the angles have to add up to 180, so you have a 90, an x, and a 90 minus x. So again, you have a 90, you have an x, and you have a 90 minus x. Those all add up to 180. And instead of 90, we write it in radians, pi over 2. Okay, so I'm going to label the sides of these triangles. Let's call the bottom A, we'll call this side B, and the hypotenuse C. Alright, let's find sine of the bottom left angle, pi over 2 minus x. So looking at the bottom left angle, sine would be the opposite over the hypotenuse. So this would be B over C. Okay, now let's find cosine of the top right angle. So cosine is adjacent over hypotenuse. We see a B on the adjacent side and a C. So notice those are equal. They're both B over C. So cosine of an angle is equal to sine of the complement of that angle. Remember that complementary angles add up to 90 degrees. If you add pi over 2 minus x and x, those add up to pi over 2, which is 90 degrees. So cosine of an angle equals the sine of the complementary angle, and vice versa. Sine of an angle is equal to the cosine of 90 minus that angle, the complement. Alright, so the way I remember these, cofunction, everything just goes with the same trig function that has co in front. So tan goes with cotangent, secant goes with cosecant, and sine goes with cosine. Alright, so back to number 9. So the cotangent of this angle is the same as the tangent, and this is a theta, these are both thetas. So cotangent of pi over 2 minus theta is the same as tangent of theta. And then a few moments ago we learned that tangent of negative theta is the same as negative tangent of theta. Alright, these cross out and we're left with negative 1. Okay, now we're going to verify some identities. So I prefer to play with the more complicated side and try to make it look like the simple side. So first thing I'm going to do is FOIL that out. So 1 times 1 is 1. Negative sine theta looks like it's going to cancel with the positive sine theta. And minus sine squared theta. So these cancel out. We have 1 minus sine squared theta. And that is our first Pythagorean identity. We know that this equals cosine squared theta. Alright, and I'm not going to box the final step because that's not the answer. The whole process is the answer. Okay, for this one, I kind of see a quadratic. So it looks a little complicated, but just imagine tangent is x. So this is a lot like x to the 4th plus 2x squared plus 1. So how would you factor that? You could factor that as x squared plus 1 and that whole thing squared. Okay, but changing it back to tangent, so this is tangent squared of theta plus 1 and then that whole thing squared. So the parentheses would then become secant squared theta, and this whole thing squared. When you square a square, you have secant to the fourth theta. Okay, for number 12, there's a few ways you can do this. So you could stick with the strategy of changing everything to sine and cosine. So let's try that. So I change the tangent in the numerator to sine over cosine. Then I change the cotangent in the denominator to cosine over sine. Alright, if I want a common denominator, I would have to multiply the 1 by cosine over cosine. So I'm going to take the first one, this one, and multiply it by cosine over cosine. So cosine over cosine is the same as 1. So this becomes cosine theta over cosine theta plus sine theta over cosine theta. And then on the bottom, we're going to change the 1 on the bottom to sine theta over sine theta. Alright, so making our common denominators, we have cosine theta, or combining the numerators now that we have common denominators. Cosine theta plus sine theta over cosine theta. And on the bottom, I'm going to combine it and flip it so that we could multiply. So the bottom, this would have sine theta on the bottom, but again I'm going to move that to the top. And then the top would be sine theta plus cosine theta. That's going to go to the bottom. Alright, so these are the same. We could cross those out, and we're left with sine over cosine. Sine over cosine, we know, is tangent. Okay, for number 13, the numerator looks like I tan by the c. I'll write that out. I tan by the c with the tangent subtracted to the other side. So the numerator is 1. The denominator, that's our other Pythagorean identity, is also 1. So this was a quick problem. For number 14, cotangent and tangent are reciprocals of each other. So anytime you multiply reciprocals, you get 1. Alright, for 15, I tan by the c is on top, so we could change that to secant squared theta. Cosecant squared theta. Let's leave that alone for now. So let's change secant. Change secant to 1 over cosine. And we could change cosecant to 1 over sine squared theta. We know that dividing by a fraction is the same as multiplying by the reciprocal. So the reciprocal of 1 over sine is just sine. And now we have sine squared over cosine squared, which is tangent squared. For number 16, we want to verify this identity. So I'm going to play with the right side. Alright, so that secant squared, I could already tell that I don't want it to be there because I want the top to just become 2gh. So if I can move that to the bottom, that would help. So secant is the reciprocal of cosine. So what I can do is, if there's a secant in the numerator, I can make that a cosine in the denominator. So if there's a secant squared in the numerator, that's the same thing as a cosine squared in the denominator. Okay, now I still need to account for the denominator. So that's I tan by the c. So that's the I tan by the c identity with the 1 subtracted to the other side. So that's going to equal tangent squared theta. Okay, and we know that tangent is the same as sine over cosine. So tangent squared is the same as sine squared theta over cosine squared theta. These cross out, and now we have exactly what we wanted. Alright. For the last one, there was a secant theta that didn't fit on the line, so I'm just going to get rid of it over here and move it over there. Alright, so we're trying to verify this identity. Looks like the left is more complicated, so I'm going to play with the left side. So we want the ER squared to stay there, because we still see it on the right. Alright, I tan by the c, so this is secant squared theta for the parentheses, and then cosine theta. Secant squared is the same as 1 over cosine squared. If I get rid of this cosine and one of these cosines on the bottom, then I have 1 over cosine theta, and 1 over cosine is the same as secant. Okay, that is all for 13.2.